Good afternoon, ladies and gentlemen. Welcome to TechGeek webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Cloud Computing, Changing Archetype for IT. This is the first introductory session of the cloud computing series that we plan to take up during the coming months. We would have more advanced session in the coming 3 months. Our guest speakers today are Mr. Pankaj Bose and Ms. Deepa Chandra, Associate Consultants at TCS. Mr. Pankaj has over 13 years of IT experience and currently works with TCS as IBM Social Business Lead. He has been working on various IBM technologies like WebSphere Portal, Web Content Manager, Lotus Domino, Quicker, and Connections, Lotus same time. He has done his certifications in TOGAF 8 for practitioners and IBM Cloud Computing Infrastructure Architect. Our second speaker, Ms. Deepa Chandra, has been involved in various opportunities and accounts playing different roles like technology advisory, solution architecting and design, project mentoring, thought leadership, delivery support, pre-sales, post-sales support. So without further delay, I introduce you all to our guest speakers. Over to you, Pankaj and Deepa.
Thanks, Mohini. Hello, everyone. Good morning, good afternoon, good evening, wherever you all are. This is Pankaj Bose and Deepa Chandra from TCS. Hello. So,
the screen now?
Just wanted to check the screen is visible?
Yeah, it's visible.
Okay. Okay. So, would like to start with a thanking note to TechGeek for giving us an opportunity to talk on cloud computing. Today's session is basically a changing archetype for IT. So actually, if you see, cloud computing has a different meaning and interpretation to every individual. Though it is still under consideration of emerging technologies, but every industry expert and IT professional is talking about cloud computing in their write-ups. Cloud computing has its own benefits and limitations depending on how we adopt this new paradigm. Applications of cloud computing has found its own way in terms of cost reduction, scalability and flexibility, storage capacity, manageability and others. There have been major players who have gone ahead with the new archetype for IT and have already shown the world that cloud computing has got a potential future in IT space. In this year 2012, we have seen big hype on some of the emerging technologies. To name a few, big data, activity streams, bring your own device, social business, and cloud computing. So today we are here to discuss on how cloud computing has brought in a new essence for IT. Moving on to my next slide. We have tried to keep the agenda as simple as and comprehensive at the same time. We will be covering need for cloud computing, journey towards it, understanding, planning for cloud computing, benefits and challenges, some key considerations that you need to know if you are adopting cloud, and Ion as TCS's cloud offering. I would like to start with a very funny quote which says, "Who needs cloud computing?" This was basically quoted in Los Angeles Times, saying that some people live blissful, digitally disconnected lives, free of smartphones, free of Facebook, devoid of a digital photo album, with snapshots of everything from their baby to their breakfast, no tangle of charging tables, no bytes of data to transfer or tap. So in today's world, if we see, it's very difficult to digest this statement. It would have been acceptable probably 15 or even 10 years ago, but times have changed and our demand of doing more with minimum resources and lesser cost has made IT professionals to explore new concepts and technologies. Moving on to my next slide. So probably what is business demanding today? We have seen that business and IT both are united in their opinion on cloud computing and its overall value. So what business demands for? It's rapid access to IT services. As in today's competitive market, everyone demands instant access to services, making enterprises respond to their customers, partners by quickly developing and implementing solutions, thereby reducing the cost of IT and increasing the business revenue. Next, proper consolidation of IT resources. For IT, asset utilization and management has been challenging forever. Proper server virtualization and storage capacity planning helps IT to decrease resource requirements and reduce operating costs. Scale up and down based on demand, which is like elastic scaling. Business demands scale up and down of IT resources or services depending on the resource requirements. Elastic scaling doesn't mean just provisioning of resources, but also application migration across platforms, or maybe maintaining proper workload during peak time, or even managing unused resources. Next one is self-service. Access to IT services on self-service approach can really help in reducing the service acquisition time. Pay only for services used. This is basically a very common demand. We have already seen this in our mobile offering quite some time back, wherein pay per second, 1 second usage. So consumers always demand to pay only for the services that they have used. So there has to be a flexibility in paying for the resources that have been used and not for the unutilized resources. Dynamic accessibility. Consumers demand dynamic and easy access to cloud that should allow them to access services anytime and from anywhere, irrespective of the delivery channel, whether it's PC, whether it's laptop, whether it's mobile, or even kiosk. So they should be able to access the services from anywhere. So these are the typical business demands today. Moving on to my next slide to discuss on how this cloud computing has evolved. So has anyone ever wondered where this cloud computing originated? When did the hype around cloud started? Who are the people responsible for the idea of grid and probably utility computing? It all started in 1960s, wherein the core concept of cloud computing evolved, where IT professionals like John McCarthy, who opined that computation may someday be organized as a public utility. And also we have another professionals like J. Licklider, who is considered to be the person who brought in the idea of cloud computing to the forefront. Okay, so it all started in 60s. During 90s, we have seen the concept of grid was introduced, based on the analogy of electricity grid, where consumers could plug into the grid and use a metered utility service, and then they are paid based on the usage of services that they have availed. Grid actually described how computer networks can be made to cooperate and made to execute critical tasks. During the era of 2000s, wherein we have seen software as a service, which was actually a replacement for ASP, that is application service provider, wherein ASP tried to provide an alternative services to on-premise software, wherein each ASP would be responsible for buying and maintaining the client-server software and making it available to customers from data centers owned and operated by the service provider themselves. But however, ASP meltdown occurred because hosted legacy applications were actually something like a fish out of water. These old client-server applications were not built to be delivered via internet, but still had all the same maintenance costs associated with the traditional deployment of legacy applications. This is where SaaS applications SaaS option came into existence, wherein SaaS-based applications were built on web-based technologies and services that are highly configurable and, most importantly, always current and updated. In 2007, we have seen a lot of interest in cloud computing have picked up, and it has gained and started gaining popularity. Companies like IBM, which released one white paper which talked about efficiency and innovation that can be achieved through cloud computing. Cloud computing was even mentioned first time in Gartner's hype cycle for emerging technologies. And this year actually saw cloud computing as one of the fastest moving emerging technologies, and it has really got a potential future in the years to come. So this evaluation can ideally be classified into three phases. The idea phase, which started in 1960s and stretched to the pre-internet bubble era, the core idea of computing, utility and grid computing. Pre-cloud phase, which started around 1999 and it continued till mid-2000s. In this phase, internet has the mechanism to provide application as a service got developed, and the cloud phase. It started from mid-2000 until date, when we have seen the term cloud computing became popular, and the sub-classifications of infrastructure as a service, platform as a service, and then software as a service got formalized.
Let us now spend some time in understanding the basics of cloud computing. Here we look into what cloud computing is, its key characteristics, what are the cloud service models, and the standard cloud delivery models which are available. So what really is cloud computing? Here we have listed the Gartner and NIST definitions, which are quite comprehensive and provide good insights into the model. Essentially, it's a way in which consumers can obtain IT resources as a service in an on-demand fashion. Here the shared pool of computing resources can be accessed real-time anywhere and at any point in time. in a very flexible manner. The significant characteristics of cloud computing are all a part of the NIST definition. Now let us look at these characteristics one by one. First is the on-demand service. The cloud services can be availed as and when needed, thereby eliminating the need and the time taken to acquire the services and reduce the time to market new solutions. Because many a times, this is what sets you apart from your competition, the time that you have taken to come up with new innovative solutions. Here, technology is not within the reach of large enterprises alone anymore. Even an individual with good business acumen can utilize the services and come up with solutions that can compete with established service providers. This is a self-service model, and with that, the provisioning of IT capabilities happen automatically, and consumers can configure and deploy cloud services themselves without additional technical assistance. Moving on to the next characteristic, these services are scalable and elastic. The resources can be scaled up and down by any extent to meet the business requirements as the transactions or the users increase and decrease. This often offers an illusion of infinite compute resources being available as and when the need arises. For example, retail and hospitality industries see peak loads during the festive season, but face a slump usually during the school and college examination times. Also, with elastic scaling, there is no need to reserve the resources to cater to the peak expected load. And in this way, the underutilization of resources can be eliminated. Here, the computing resources are shared through resource pooling to address the needs of several consumers simultaneously. This is done using a multi-tenant model. Here, the consumers work in logical isolation, though underneath they share the same physical resources, and this can be allocated and deallocated dynamically and automatically. The services are metered by use. Here the usage can be tracked based on resource consumption, that is per transaction, per user, per organization, etc. Or it can be tracked based on resource utilization, that is how much of CPU is getting used or what percentage of memory was allocated and so on. And this provides the flexibility of multiple payment models. So the payment has thus moved from a contractual model to a utility billing model. The users can pay for the resources or services on a short-term basis. So the upfront investment overhead is done away with. Extensive network access so that services are accessible easily on a real-time basis. And this is a critical success factor for cloud computing, as with a good network connectivity, a significant challenge in providing cloud services seamlessly will be taken care of. Moving on to the next slide, let us look at the standard cloud service model. Cloud service offerings are available in 3 standard service models: infrastructure as a service, platform as a service, and software as a service. Infrastructure as a service is a cloud service model which provides the basic building blocks using which you can build on the infrastructure required to run the customer application. Studies have shown that companies use a significant portion of their IT budget in the upkeep of existing infrastructure. Instead of maintaining expensive data centers and managing underutilized servers, now consumers can opt for the computing resources virtually and pay only per consumption. Some of the examples here would be Amazon Web Service or the IBM Business Development and Test Cloud. Moving on to platform as a service, this is a cloud service model where computing platform, that is the software and the product development tools, are delivered along with their underlying hardware infrastructure as services. Here the consumers can then create the applications on top of this. Standardized APIs are mostly provided so that the users can easily develop the applications. A few examples here will be Google App Engine or the force.com from salesforce.com. The third type of cloud service model is SaaS, where the application along with its software and hardware infrastructure is provided as a service. The application is generally provided in such a way as to support multiple tenants and is typically accessed via a web-based front end. Hence, there is no need to support or no need to install and run the application on the customer's machines. Some examples here would be Google Docs, Lotus Live from IBM, Gmail, etc. Moving on to the next slide. This slide gives a snapshot of what resources are available as services under infrastructure as a service model. Under this model, the consumer can make use of servers, storage, network, and other
Deepa, are you there? There's no sound from your end. Deepa, are you there? We're not able to listen to you. I'm extremely sorry for the inconvenience. The speakers are logging in shortly. They just got disconnected due to some technical issue. Pankaj, are you there?
Yeah.
Okay.
Mohini, can you just let us know which was the slide at which we got disconnected?
Can you please start from the last slide, the previous slide?
Software as a service?
No, platform as a service.
Okay.
IaaS, infrastructure as a service. Yeah.
First of all, sincere apologies for getting disconnected.
Okay. Let us look into what infrastructure as a service is. Here this slide gives a snapshot of what resources are available as services under the IaaS model. Here the consumers can make use of storage, network, servers and other resources and build the operating system and the application on top of it. Essentially, the consumers can own the operating system and the applications deployed on it, but cannot manage and control the underlying cloud infrastructure. Moving on to the next slide. Under platform as a service, the development tools and software along with the underlying infrastructure are provided as a service. So customer can use any means to develop the applications and they own that portion, although they cannot or do not manage and control the software and the underlying hardware components. Under software as a service, the application is bundled along with the underlying infrastructure by the cloud provider, and hence the consumer has limited control over it, except maybe to customize the look and feel of the application in some cases. Most are written in a standardized format to cater to the needs of multiple users. Moving on to the next slide. Here the standard cloud deployment models are depicted. There are various flavors to these models as well, but we will cover the basic ones. A public cloud is one in which the services are provided by a third-party service provider to the users in general. Here the cloud provider owns the computing resources that were used to deliver the cloud services. Since the services here need to cater to the user community at large, standardization in services is where the emphasis is on, and those services having mass appeal dominate the public cloud. Storage solutions, conferencing services, whether audio, video or web, development and test environments, mail services, or any data-intensive workloads where sensitivity of the data is not a concern are all good candidates. Some of the examples are Google App Engine or Amazon Elastic Compute Cloud. The private cloud is one which is owned by an enterprise. It can be hosted and managed either by the enterprise's own IT team or by a third-party service provider. Here the enterprise has greater control on how the services are maintained, thereby taking care of data security and reliability concerns. Typically, services are provided via intranet to the enterprise users only. And hybrid cloud marries the best of both worlds by integrating public and private cloud models. This model is widely used as it allows enterprises to keep sensitive data and customize applications within their private cloud while utilizing the server and storage services from the public cloud.
Okay, now let's have a look at if you are planning for a cloud computing, what all parameters, things that you need to look at it. This shows a reference architecture of cloud computing, wherein if you see there are basically three different kinds of communities or groups. Obviously the cloud service provider being the core, and on one side it's cloud service developer and on the other side the cloud service consumer. And as mentioned by Deepa, we have all the service models like SaaS, PaaS and IaaS as the services. Now, and for all these services, we need to really consider a virtualized environment, whether it's storage, servers, or network. And when the cloud service providers tries to implement any service, they really need to ensure the compliance, the security, the quality, and the performance of those services before implementing it on the cloud environment. And before the cloud service consumer can actually consume those services, there could be another layer of APIs through which they would actually avail those services. Now, either depending on the deployment model, either they can access the services via VPN network or it could be an enterprise network. And moving forward, irrespective of the delivery channel, whether it's laptop, desktops, kiosks, or any mobile devices. So this is a typical reference architecture. I'm not getting into a deep dive into it. Moving on to my next slide. Let us look at the infrastructure and the environmental components for a cloud computing. First is the security. It's basically evident to measure the risk related to data integrity and security in the cloud environment. Enterprise needs to follow the regulatory compliance through timely audits and locate the data in order to ensure the privacy and authenticity. As data is very sensitive, proper access control and encryption is highly required in a cloud environment. And also a proper strategy and plan to backup and recovery of data should be in place. Next is the server component. Based on the adopted cloud model, whether it is private, public, or hybrid, location and management in regards to hardware become very important, whether it would be owned by the enterprise or whether it would be owned by the service provider. That's very, very important. In any cloud model, a proper hardware sizing and capacity planning for every server should be done so as to provide a high availability and scalability. Because this is typically a very important and complex exercise of sizing and capacity planning. So that's very vital and important. Enterprises opting for private cloud may reutilize their existing servers if they want with virtualization technology to build their own cloud environment. Next is the storage component. As with servers, consumer-owned storage infrastructure is not a requirement when using a public cloud. But yes, for a private cloud, users will contribute storage to the overall solution and can choose from a number of different types based on their actual need. Storage like NFS, NAS, and many more be a part of users' cloud infrastructure. So storage virtualization may be used in the cloud infrastructure as well. Next is the network, which provides the connectivity backbone for the cloud solutions. Regardless of whether a user is pursuing a public or private cloud, the networking infrastructure could be a part of the solution. Many public clouds allow for creation of virtual private networks that securely communicate with the user home network. But for building private clouds, their networking infrastructure provides the connectivity backbone. Regarding application and data, applications must be thoroughly analyzed before moving on to the cloud-based environment, as those must be able to run in the virtualized container, and their components can independently scale in elastic cloud environments. Similarly, in case of data, migration, connectivity, version, storage capacities must also be considered before moving on to the cloud. Secured access channels are required to establish between application and the data in case of hybrid model. That is, your application may be on the public cloud and your data may be on the private cloud. So that's where you need to ensure a secured access channel. But you need to ensure all legal and regulatory compliance to be properly met before moving to a cloud environment, especially for the public cloud. Next is automation. Automation plays a critical role in realizing the full value of cloud computing. Customers' existing automation systems should be examined thoroughly to determine if it is possible to use them in conjunction with the new cloud computing environment. Last one is virtualization, wherein the computer resources are dynamically and automatically provisioned as demand varies. In virtualization, existing virtualization technologies used by the customer should be identified and evaluated to determine if they will integrate with a new cloud computing environment. This is very, very important. If the cloud migrate means new virtualization technologies will be used, existing infrastructure and application should be tested with this technology. Otherwise, your applications may not work in a desired manner. So these are some of the key infrastructure and environmental components that you need to be assured about. Moving on to my next slide, wherein we'll discuss on the benefits and the challenges.
Okay, so let us now touch upon the advantages of being cloud enabled and the current limitations. The benefits have got covered more or less in the previous slides. So as a quick recap, let us look at how cloud computing helps. Reduce costs, be it a reduction in hardware costs due to server consolidations and economies of scale, or reduce IT operational costs through service automation, reduce maintenance costs since no longer does the enterprise need to maintain expensive data centers, reduce startup costs, or the substantial savings through flexible pricing models. All of this could attribute to the reduced cost. This benefit is most evident as a tangible outcome and hence is one of the biggest drivers tilting the enterprise's inclination towards cloud adoption. Increased storage as consumers are no longer constrained by on-premise storage options. Now they have virtually infinite possibilities. Here the services are highly automated, thereby improving the time to market new solutions and letting enterprises respond faster to competition and improve overall efficiency. Since the services are highly automated, it reduces manual intervention and this in turn contributes to the reduction in overall cost. Flexibility through what? Through elastic scaling, through better price models, through multiple service options. This is how cloud computing brings in the flexibility. It allows anywhere, anytime access to resources, leading to increased mobility. And abstracting the IT operations to the cloud has allowed enterprises to shift the focus towards their core business and innovation. And the less apparent but socially relevant benefit is the energy savings, resulting from the same physical assets being used by multiple entities, as data centers no longer need to be managed individually by enterprises. Challenges. Earlier enterprises had explicit knowledge of where the systems and data were located, who's handling them, where it will be backed up, how secure it was, how compliant they are to regulations, which is the disaster recovery location, and so on. By moving the workload to the cloud, there is a lot of abstraction on all these factors. So the enterprises are concerned about the vulnerability of their systems and data to malicious users, to outages, to security violations, and so on. So the very factors which contributed to the key characteristics of cloud computing, like location independence, shared resources, etc., are also causing enterprises to rethink about public cloud adoption. But analysts are predicting a change in the scenario as more and more cloud providers are looking into addressing the security concerns.
Now, let's have a look at some of the key considerations, like what you should know if you are really considering a cloud environment, like what type of skills you would need to know. One need to have a better understanding of what service model is required and then which delivery model is the right fit for the business requirement. Moving on to my next slide, this tells some of the skills that you would require when, for instance, business and financial skills, wherein advocates or proponents should be able to make an appropriate business case for their cloud deployment. They should be able to calculate a proper ROI, it's a return on investment, and monitor the same metrics based on the business performance versus the cost of subscribing or supporting to the cloud. Cloud computing, if you see, it's a very much, it's basically an influential business tool, and evangelists have to make it work for their enterprise, because it's not going to work on their own. Second one is the technical skills, wherein experts should be able to decide on the correct option of which service and which delivery model for cloud computing to opt for. The knowledge base would need to be heavily focused on the internet capabilities, but knowledge of open source tools and languages are also equally important. And other competencies like maybe Java, .NET, and some other framework may come to forefront in addition to virtualization. Third one is the enterprise architecture and requirement analysis. When it's basically very vital for putting out a proper roadmap of what services, whether it's owned or and managed by your IT or by your service provider. One should be able to understand the language of business, what business is talking, the way they are talking, and they should also be able to respond in the similar manner. Because in front of business, if you talk technical aspects, they may not understand that. So you need to be very aligned with the business users. And yes, a clear understanding of service-oriented architecture is a must-required skill here. Next one is the project management skills. See, any solutions deployed in cloud environment are treated as a typical project that you would build, test, and implement in any other environment. And for that, you need to have a variety of skills ranging from people management, time management, vendor management, and others. Since cloud computing offers end users the potential to run and access services, effective project management skills are needed for successful implementation of cloud projects, as they are intended to design or designed to replace on-premise systems. Next one is the security and the compliance, understanding of which is especially the security protocols are very, very essential, irrespective of whatever type of cloud is being deployed. In regards to this, a clear understanding of mandates and regulations should be required, which is like very specific to geography, because for every geography there would be different security and compliance rules. So you need to be very, very knowledgeable about that. Data integration and analysis skills. See, as data is the most valuable element in the success of any business, and also data helps in making business decisions. Data generated through cloud-based systems mesh seamlessly with on-premise legacy systems. Today, data professionals are in high demand who can design systems that can consume huge volume of data from the cloud, or use the cloud to provide analytical environments. So you need to ensure that you have all these skills in place when you're going for a cloud environment. Moving on to my next slide, wherein I just wanted to mention that what experts are saying today, wherein we have just quoted one from Gartner and Forrester. So it's basically, it says that cloud computing would move out of the shadows and become a mainstream technology by Forrester. Some of the major players, depending on the service model, I request you to have a look at the snapshots. So where is cloud computing heading to? So it has been found that, that there is going to be a change in trend where the large vendors entering cloud computing will accelerate. All major development environments will come as offering in the cloud deployment options, and the next generation of middleware of the cloud will rise in dominance over our traditional application servers, and then we can keep adding more to it as this particular concepts move forward. And then wherein Gartner says at the year-end 2016, more than 50% of the global 1,000 companies will have stored customer-sensitive data in the public cloud. And there's a very similar statement by IDC. It says that cloud computing maturing this year, more organizations will start to move their IT infrastructure from on-premise to off-premise.
Okay. Now with the understanding of cloud computing that was built over the previous slides, let us look into one of TCS's in-house cloud offering as a case study on how cloud adoption has helped small and medium businesses to meet their business needs. Before we jump into what this cloud offering is all about, it is essential to look into some of the challenges faced by the small and medium business segment. What we have found is 60% of the SMBs lack any form of IT, and is thus a largely untapped customer segment. Typically, here the segment has limited technical expertise on how to set up and maintain IT services. Sometimes don't see the value add in maintaining a full-fledged IT team, given the size of the company. Could be as less as 20 people or lesser, and could go up to a few hundreds. They may have space constraints as far as keeping the computing assets is concerned. Sometimes lacking the know-how on which applications or services suit them best. They may find it difficult to retain qualified IT personnel and also find the huge upfront capital investments as prohibitive. In addition, some of the businesses grow very fast, and sometimes there's a need to scale down as well. Now moving on to the next slide. These were some of the challenges that came up time and again as TCS interacted with multiple SMBs to understand their needs. To address these challenges, TCS has come up with the platform called Ion. That's the integrated IT as a service. So TCS owns the IT department of the company, and the company can pay per user of features. They don't have to worry about upfront cost or think much about supporting IT services. And all these IT services are provided on the cloud. And the services include a set of pre-integrated hardware, software, network and application. It delivers on-demand business capability, allows for easy scaling up of IT needs with business growth, and functions on a build as you grow and pay as you use service model. It's done through a hosted platform. It currently addresses the core industry vertical solution needs of manufacturing, wellness, retail, education, restaurant and textile. For example, in the case of manufacturing vertical, the solutions will include material, sales, stock, production, etc. While in the case of retail, it will be point of sales, warehouse, store inventory, etc. These applications help customers to drive their core business processes in their organizations. With this, we come to the end of the session. Hope this session has given you useful insights into the nuances of cloud computing. Thank you.
So we are open for any questions if somebody wants to have any from the audience. I think
Can you see the questions, Mr. Pankaj?
yeah, we are just
Okay, let me take up this question on what is self-service and how is it different from in-house development by Pradeep Patil. See here, there is no need. I mean, it is given in such a way that you don't require external help to operate on that service. It's basically provided along with service catalogs and makes it very easy to use. And that is why it is different from in-house development. I don't exactly know what he has meant here. Normal service written in-house would still require some amount of deployment skills.
Okay, there is another question asked by James Kalapalli. What is the difference between an enterprise and a service provider when we are going to adopt it? If I've understood the question correctly, the response, the answer would be like, see, when we are saying enterprise and service provider, here depending on the service model or the delivery model, whether it's a private or a public cloud, depending on the manageability, if the enterprise are owning the entire environment, and that's where it's the enterprise things comes in, and then if it is being hosted and managed by a service provider, then it's basically the service provider. So whether it is managed by the enterprise's internal IT team or whether it is managed by a third party. So that's the difference between an enterprise and the service provider.
Adding to that point, Here in this session, we have used enterprise for those who are utilizing the service, and the service providers are the ones, or enterprise would be the service consumers, and service providers are the ones who are providing the service to the service consumers.
Somebody, Vijay Kumar is asking how to manage version controlling if the same application needs to be customizing in a different market. See, version controlling is actually you need to use an appropriate tool or software. Okay, so in terms of services, it's basically like how you manage basically wherein you provide a standardization approach for providing the service. This is how you manage the version control.
See, James.
Vijay, it's Vijay.
Okay, Vijay. In these cases, mostly where public cloud services are concerned, standardization is the key. So it is the same standardized option which is given for multiple tenants, and rarely do you have the possibility of giving specific different versions, and even when that is given, it is the responsibility of the service provider to handle the service version.
I think this is the last question. Is SaaS and paying only for services used are related? Is it something where organizations do not want to invest in infrastructure to reduce the cost? See, though the question is not very clear for me to understand, but see, paying only for the services, it's basically one of the characteristics of cloud computing, and wherein the SaaS is one of the service model of cloud computing. So these two are actually two different things, and not are the elements that can be compared between. And obviously, to invest in the infrastructure, if it is a cloud environment, if you are not owning the infrastructure, obviously you are reducing the overall cost. So I think that's it. Mohini, if would like to conclude it. Hello?
Yeah, Pankaj.
Yeah. So do we have any bandwidth?
Yeah, we can take questions.
Okay.
Okay, there is a question on what is Ion? Is it some sort of cloud service that TCS is providing? It's asked by Sandeep Sankalapur. Yes, it is TCS's cloud offering where IT is offered as a service. This is something which we have applied a patent also for, since the IT as a service lets multiple tenants use the same service concurrently. If you want to know more about it, you could check the website TCSIon.com.
Okay. Another question by Chavakula Krishna says that as it is a multi-tenant architecture, if my application running is in one server, if that server gets failed, how can my application be recovered? See, in typical cloud environment, you also need to do a proper planning for your failure and recovery, wherein you need to have a clustered environment as well, wherein if there is a failure on one server, so that your application or data would be routed to, or rather you would be routed, or the data access would be routed to the clustered environment. So you need to have a proper clustering done for those kind of failover.
There's a question from Darish Rajan on what are the courses available in the market to get an expertise on cloud computing technologies. What we would suggest is you could start with the online sessions and if you search on the net you would find multiple material on what cloud is. Currently IBM and a few other players do provide certification courses, and if you go through the certification material, it is quite comprehensive and it gives you or lets your basic concepts be thorough. There's another question on Ion again. Are there any competitors for TCS Ion in the market? This is asked by Vidyashankar Lakshman. Currently, there are no players addressing the end-to-end technology needs of SMBs. There are fragmented providers and there are isolated solutions available, but this is the first time somebody is addressing the complete integrated IT as a service for SMBs. What Gartner had mentioned is that it's a one-stop shop for all IT needs is where TCS will have an edge.
There is another question by Santosh S. What is the approximate cost saving over 5 years if shifting to cloud computing for an organization with approximately 100 personnel and reasonable infrastructure? Santosh, typically this is an exercise that needs to be done, and with these kind of only based on these two parameters, it would be very difficult to come out with cost saving factors. But there are other factors that needs to be taken care, like maybe how much today you are spending, what are the different infrastructure costs that you are incurring. There are some procurement costs, there are some recurring costs, maintenance costs. So that's basically some kind of an exercise, or maybe in the form of a spreadsheet or whatever, need to do it in order to arrive on the actual cost saving. Okay, Mohini, I think we are done with the questions.
Well, thank you so much for the insightful presentation, Mr. Pankaj and Ms. Deepa. I'm really thankful to you both for conducting this webinar. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of the webinar would be available on techgeek.com by tomorrow. More sessions on cloud computing would be coming up in December and the coming months. Thank you all. Have a great evening.
Thank you.